Leah.
Hello, Philip.
And that's really easy when we're close to each other. Now, if we go a little bit further away, we have to raise our voices and shout a little bit.
You have to what?
Shout a little bit.
To what?
Shout!
Okay. So if we're much further away, it's hard to talk to each other. How can we do that? Well, we could walk towards each other, but that's not always possible. That's not always convenient, especially if something like a great big mountain ranges in the way. There's got to be another way to send a message. We're not going to talk to each other. We could write it down. Write it down, okay. Okay, we'll write it down.
But you're writing down a message. How's that going to get to me?
Yeah, how are we going to get it to him without me actually carrying it to him? There's another way. Does anyone want to volunteer to be our postman? Oh, I think we have the fastest hand here. Do you want to come here? Give a big round of applause. The best thing about being a postman is if you go to post a letter, you have to pay for a stamp. So we've got some chocolates for you to say thank you. Please, can you carry that over to Philip over there?
Wow, that's good. On time posting. Thank you very much. You can keep your chocolates because we paid you those, and yes, go back to seat, which is
Give a big round of applause.
So I now have a message which says, "Hello, Philip." Well, that's really nice. And we didn't have to move a huge distance across the lecture theatre to send that message. So I think I'd like to send one back. So, hello. Yeah, so let's find someone to do a message. Okay, we'll do. And you can have some jelly babies. So take the message to Leah for me. Thank you very much.
Unfortunately, the lecturers haven't learned yet you can never trust a volunteer. So there goes the message.
We've got a bit of a problem.
The Royal Mail.
That's possibly a bit too political. But one of the things about communicating is we need to make sure our messages actually get to where they want to. We don't have rogue people destroying them or stealing them. And we also want to send them as fast as possible. Okay, so we don't want postal apps to come in.
So there's some other fast ways of sending messages that we've had for hundreds of years. We've got some photos of them. So you can send messages via flags, like on the far left. You might have heard of semaphore, something like that. In the middle, we've got a beacon. Has anyone seen a beacon signal before? It's one way you can send signals over really long distances. Something like, there's an army invading, come and help. But the signal can only mean one thing. You have to just say that's the only thing the beacon can say.
That's almost like a code, isn't it?
Almost like a code. And the third one, before we skip on, that's a lighthouse. That signal is saying there's a rock nearby, but that's all a lighthouse can say.
That's quite useful, right?
It's quite useful, especially with boat.
Are there any other ways of using the code?
Yeah, there's a few other ways. Does anyone guess what this is about? Let's shout out. Morse code. Morse code, yes. So a code can be used to send information quickly. And it can offer symbols for messages.
Okay, so all the letters in the alphabet have a different code. So you can see here that A is a dot and a dash. And we can send it with a torch, so we have a dot and a dash. And if you had a table of Morse code, then you'd know what that meant. So what happens if I run into some trouble and end up, as I know, falling over and breaking my leg? Well, I can send out a code saying help me, and that code is often called SOS. If you look on the charts, what's S there? Can anyone tell me? Yeah, look at that. Dot, dot, dot. There's 3 dots there. And what's O? Yeah. Dash, dash, dash. So if I'm in trouble, I can send out a message which goes dot, 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 dash, 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 dot, dot, dot. And people know that that means help me.
So the first time that was used was when the Titanic was sinking. I think they did get help, but maybe not as much.
A little bit late, really. Okay, so that's 2 ways we can use the code. But also, we had someone steal our message, and we don't want that to happen. So we can use a code to stop people stealing our messages, hopefully. And the nice person there in the photo is Julius Caesar, you may have heard of him. And this is a thing called the Caesar cipher. And it's a very simple code, but it's a good way of seeing how these things work. So if we take the alphabet, which you can see right along the top there, A, B, C, D, etc. And then we say, well, if you've got the letter A, we'll make that the letter Z. And if you've got the letter B, we'll make that the letter A. And keep going like that. So we just shift in the alphabet. We can take a code, so if we were plotting something, we might write evil plan. So if we use our code here, it might look a bit more like this. Jerk, oxen, which I'm sure you will understand. So that works quite nicely, but only if you don't know what the code is. Because if you've got that table at the top, and also there's other clever ways of doing this, you can quite easily break my code. So it works quite nicely for very simple things, but if you want to send a very simple message, we need to be a bit cleverer than that. So how can we stop anyone else reading a message? Okay, well, we could come up with a really, really strong code, but the code's only really, really strong if only we know how to use it. So you don't want to tell everyone else how you code something. And that's a bit like putting a padlock on a message. So you have a message, just close the padlock, and then nobody else will be able to get into it. So should we have a go at that? Yeah? Why don't you write me a message? So she's just writing a message normally, but then she would put a very, very complicated code on it. And that's like putting it in a box. Very funny box, and locking it. So Leah has her own padlock, that's her own code.
I'll keep this safe. Otherwise it won't work at all.
Okay, so the padlock goes on the box, and now she's going to send it. Oh, you lot. And you lot don't look very trustworthy, to be honest. So let's pass it out. And I want you to pass it over there. Avoid the guy in the blue t-shirt, because we know that he's already in trouble. And so pass it up the lecture theatre, so that some more people. Can you get into the box? Don't try too hard, please. But there's a lock on it, so you can't easily get in. Okay, let's pass it across now, so that it gets there eventually.
Can you get in? Is it safe?
Even a catch, but you can't get into the actual box. Well, that looks really nice and secure, doesn't it? Okay, let's pass it down to the front. Let's see if I can actually get into this message. That's very well locked. It's also good to see that none of you are in the habit of carrying false cutters around. And then you can pass it to me. Now I have a box with the message in it, but I have a problem, because I also don't have the key. Well, that seems like a bit of a stupid thing to do, really, doesn't it? I don't want to shout at once. But maybe I could do something a bit different here, because I also have a very, very secret code. And I could take my very, very secret code and put that on the box. So I've taken Leah's code, coded message, and coded it again myself. So now there's two padlocks, there's two codes on the box. And this time let's pass it along the front row. Can you get into it? Okay, do you want to pass it along? But the thing is, if I give you the key, then my code isn't very secure anymore. So it's lost the point of actually having it. Okay, and now Leah's got a box, and can she open it?
What do you reckon? It's got my padlock and its padlock.
But what can she do? Any ideas? What could she do? She could cut them, but we don't want to do that.
That's cheating.
That's difficult as well. What do you think? So we're going for the criminal approach. Well, that could be a good idea. And if you were trying to steal the message, that would actually work very well if you could do it. But let's say these keys are very difficult to make. There's one thing she could do. So what over there? Red scrubbing to the left. take hers off. That's a good idea. And then she can send it back to me. Now, we've already been on the lecture theatre a few times, so let's do it the good way. Thank you. I've still got the box, and it's still locked, but now I have the key, and I can open it. So we've managed to send a message. It's had to go backwards and forwards a few times, but we've managed to put code on it so that you can't break into it, and what we have sent is really, really secret. And it says, Philip Spells. That was worth the effort. Okay. But it's quite a useful way of sending a secret message, so we can do that and keep things nice and secret.
So these ideas all work well if we just want to talk to each other. There's one way we can do this in real life, like a really simple telephone.
So like a couple of bits of wire, and a microphone and a speaker.
It's a bit too high tech.
Yeah.
We have any other budget left for that?
Oh, wow. What's he running for? Check this out. Oh, yes, it is. Oh, should we go in there? Hello? Hello? Ooh. You want to see whether it can get through the glass? So you're going to have to go right over there.
Oh,
Okay. You see, if you're being really quick, you would shout really loud a bit, so it's singing the house around it. Okay, so we've got a telephone, and that works quite nicely. It's really simple, and we can talk to each other.
But what if we all wanted to talk to everyone?
Well, that is a...
That's just, yeah.
You'd also want to be careful that no one else would find their own phone into the line as well. So this is where we have to start being clever about codes again.
So if two of us want to talk to each other, we just need one phone. But if four of us want to talk to each other, the first person needs 3 other phones to connect to the next 3 people. The second person needs, he's already got one phone line covered because the first person had it, needs 2 extra lines to connect to the next 2 people. The third person needs 1 phone to connect to the last person, and the last person we've already covered with the previous 3. So that's 3 and 2 and 1, so 6 phones to connect 4 people to each other. 8 people, we do the same maths, 28 phone lines. 16 people, we do the maths, that's 120 phone lines. We're saying 100 people.
Could almost be 100 people in this lecture theatre.
Is that 100 people here, maybe?
Should we try connecting all the string phones?
Yeah, how many string phones are we going to need?
Anyone like to guess?
250.
That's a lot.
It's a lot.
What do you think? 150. Would you like to see? Oh, you've got, what's your guess? 1,000, that's a very big number. Here's the actual answer. 4,950 phones.
And there's the maths doing it at the bottom right-hand side. If you want to figure out how we can do it.
All that allows us to do is work out if we had any number of people, how many phones we need. But the problem is, it gets very big, very quickly. So maybe we need a bit of a clever way. So there's you. I hope you're smiling still. Yes? Good. Okay, so you are the centre of your universe, obviously, like the centre of the slide here. And hopefully, at any luck, you have some friends. Yeah, good. And you know how to talk to your friends. So you can connect directly to them, because that's nice and easy. Okay, but your friends also have their own friends. That's nice. And your friends' friends know how to talk to your friends as well. So there's all this sort of grid connecting everyone to everyone else, but not necessarily directly. And actually, it doesn't really matter if you don't know how your friends know other people, because we can try sending a message to someone we don't even know a long, long way away. And all we need to know is their address, because we generally have a good idea of where people live roughly. So imagine I had a friend in China, for example, in a city in China, say Shanghai, and I don't know anything about China. Imagine I'm very stupid. So I want to send a message to someone there, and I would send it to someone who lives in China, and then they can send it someone who lives a bit closer to the destination, and eventually you can get, hopefully, the message to where it needs to go. So what we need to do for this is have a message, an address for where it's got to go to, and hopefully we could get the message to the destination as long as we know roughly where it's got to go. And that's a bit like how the internet works. And so what we need really is an internet. So, hello internet, that's you. So what we've got is, we're all like individual computers out sending messages. And what we've got is a couple of paper aeroplanes. And these are the little bits of information that go flying around the internet. I'm going to write a message on them. Can you do that? I'm going to be nice. Just to make it honest. So I put in, hi there. See if we can get this to work. And I need to know where she lives. So we've got an address book. And we need to know what her address is. So his address is yellow. We're going to use colours for this. So I get to a yellow address sticker.
What kind of address do we need to fill it? Blue? And blue.
Okay, and if you look around the lecture theatre, you'll see there's some buckets. So this one's a blue one, so this is like my computer. And there's a yellow one over there. And we're not the only people on the internet. So there's a couple of people, a couple of buckets at back, there's a green one there, and there's a red one over there. And what we're going to do is send our messages into the internet, and they're going to get picked up by a computer on the internet, that's you. So if a plane lands near you, you just need to look at the stick on it and go, well, where's that got to go? And you say, well, it needs to go roughly over there. So just throw a couple of people down the road, and hopefully we're going to get the message from where it's being sent to where it needs to end up. Should we give it a go?
You ready?
Yeah, okay. So I'm going to send one right to the top to start with. Should we give it a go? So don't throw it too hard, please. It would be very sad to have anyone blinded in the course of the lecture. So which direction? Look at the sticker. Which bucket has it got to get to? Throw it to someone else who's a bit closer. There we go. Okay, and that's basically in the bucket. So if you're near the bucket and the plane lands there, that counts as arriving. And my computer. That's very nice. Right, so I have a message. You got a message?
Yep.
What does yours say?
Hello, Leah. What does yours say?
Mine says that it smells really bad. Right. That was quite nice though, wasn't it? Apart from your message, of course. Because we didn't actually need to know where the message was going. Well, we needed to know what the address was, but we didn't know how to get there. And none of you actually needed to know the best route to get from there to there. It just sort of works itself out, which is quite neat. Okay, so we made both. That was a nice simple message. What if we wanted to send a picture like this work of art?
What's it supposed to be?
What do you think it is?
Smiley face.
Yes!
Excellent.
I wasn't sure whether anyone would actually be able to tell what it was. Okay, so the problem with the picture is that there's a lot more information. Because people say a picture's worth 1,000 words, and you can't fit 1,000 words on a paper aeroplane. So we're going to send a slightly different message this time. And instead of having something written like, hello dear, something nice like that, we're going to have a message that's the colour of the plane. We're still going to put a sticker on it, but there's one other piece of information you need to know. Can anyone guess? You have your hand up really quickly. Sorry? We need to know how many squares, and it's to do with the number of squares. We need to know where they are. Very good. So we also need to give them a number. So we've got 25 different colours in a grid. We don't know how the grid works. Sorry, 25 different squares. Very good. So our message needs to be the colour and its position. So whatever the numbers are there, and and we need an address. Right. So I think why don't you send me that message?
Are we ready to encode this picture? Okay. We've got some planes. What should the first plane be? Yellow, right? Good start. What should it say? One, okay. Right on.
Finally, what about a picture? Do I love them?
One. What else does it need? What other bit of information is necessary? Where does it need to go to? I'm going to send the next message.
What's my colour?
What's colour?
Oh, actually, what we need is the addresses back in a second. But just in case you've forgotten.
So we need a blue stick as well. Excellent. Okay. Can we have a picture back, please?
Yeah. Okay. Good.
Oh,
Hang on, if I just do this properly. There we
Yay.
go. Too much technology.
what about plane number 2? What colour will that be? Blue. Awesome. What else do I need to? Do I need to write number 2? Blue sticker.
So do the colours of the stickers change at all if that all comes to me? No, because I'm always blue, my dress is always blue. Unless I move, but we're going to set this, I'm going to say the same place. Okay, what's the next one? Good?
Oh, yellow.
I'm getting the hang of this now.
Blue sticker? Yep.
Yeah. Good. So there's only 2 pieces of information, so 3 pieces of information we need to send. One of which is the colour, one of which is the colour of the plane, one of which is the number, and one of which is the address. And so the final one we've got here is blue.
Fine. Yeah.
Okay. Well, we're going to do a bit of a blue piece of jumping, okay?
Yeah, do you want me to watch number 25 from planes?
So what we're going to do is try sending that message from there to me by you, the internet. Should we give that a go?
Are you ready, internet?
There's one other thing though, before we start off. We're not the only people on the internet, and so we have loads of other messages. So there's going to be some other messages flying in from elsewhere. So keep your wits about you. Try not to get hit in the face too much, and be nice when you're throwing one. Let's see if we can get all the messages which should come to me, and everything else to everyone else that they should go to. So if it's a yellow sticker.
The address is the important bit of information for you.
Ready? Okay, let's go. Okay, so remember that there's 2 addresses at the back, which are green and red, and if they land quite close to you, just try and get them to the right place. There's a lot coming off the front here. Close enough. How are we doing? How's everything going, internet?
Good.
Good? It's a strange feeling having to dodge through that. Is that the blue one? Right. That's the blue. Okay. Shall we see if we can get the same picture that we have over there up here? So, can I have a volunteer actually? You look very enthusiastic. So what I want you to do is take a paper plane out of the bucket, tell me what the colour is, plane, and tell me what the number is. And then I'm going to try and make the image up here on the back. We'll start with the first one. On your finger, you just go away. That's that. It's a big one, and it's number 2. Okay? Let's keep going. We need to get through lots of paper planes. So there we go, there's number 4. The other one is number 12. 24. Okay, that's very good. Number 1. It's almost like big, but actually more fun. What is that one? 16. That was yellow. What colour is that? Yellow? Does this look like something we've seen before? Was that 19? There we go.
25.
That's yellow as well. 15.
22.
This is looking good. You're reading into it. Most of the messages are actually there.
The best bit is this is written up in every practice. What was that, number 10? Good.
8.
When you get this one set, it should be next to each other. Can we have this to each other?
21.
See one. Say yellow. Number 6. Okay.
14.
18.
3.
Yeah, that's yellow as well. 3. Red one. 23. What's that one? Is there another one? Oh, we've lost one. We'll find it. Number 11.
So close, internet. So close.
Well, we can do clever things with the images actually. We look at what we've already got. So that looks kind of symmetrical. So that was yellow. And that's yellow. And that's a bit about information processing, which I didn't intend to put in the lecture, but I think that's quite useful. Okay. Now, it's not the neatest drawing in the world. Does that look similar to this? Hooray! Well done. So that was some excellent counting. Thank you very much. And you also need to give yourselves a round of applause because you were the internet for maybe 20 minutes and you successfully sent a message. Did the other people manage to get their messages as well? Is it linked to those buckets? Yep. Okay, so all at the same time, we managed to send lots and lots of information in lots and lots of different directions without knowing too much about it. But magically, you said put it in one end and it comes out perfectly as you want it.